Welcome to a quiet corner of the universe, a place where science slows down curiosity, softens and wonder finds its breath. Tonight, we drift into the most mysterious current we all move through, yet can never quite hold time. It hums beneath every heartbeat, glows in the light of distant stars, and lingers in the space between thoughts. Time shapes our memories, guides the rhythm of life, and stretches from the birth of the cosmos to the stillness of this very moment. So as you settle in, let your thoughts uncoil and your breathing find its own rhythm. Let go of the ticking world for a while. Together we'll wander through centuries and seconds across the galaxies of memory and matter, tracing how time flows, and sometimes how it stands still. Time does not live inside the ticking of clocks, nor in the steady rise and fall of the Sunday. It lives within us, moving in quiet rhythms that change with mood, memory, and meaning. Some days stretch endlessly, their minutes unfolding like the surface of a calm lake, where every ripple lingers. Other days disappear in a blink, rushing past as if the world has quickened its pulse. Though we count the same hours, the feeling of time is never the same twice. It bends to our attention, expands with wonder, and contracts with routine. We think of time as fixed, but in truth, it is one of the most personal experiences we can have, an invisible landscape shaped by the mind. Inside the brain, time is not kept by gears or hands, but by pulses of awareness. Deep in its structure, regions such as the basal ganglia, cerebellum, and prefrontal cortex form a network that acts like a hidden metronome, a soft ticking no clock can hear. This internal rhythm allows us to sense how long things last, to predict motion, to coordinate speech and thought. Yet it is not steady. It drifts with emotion. When we are engaged, attention narrows and time seems to dissolve. When we are bored, the brain counts each passing moment, as if amplifying the silence between heartbeats. In what psychologists call the flow state, described by Mihaly Csikszentmihalyi, action and awareness merge until time itself loses form. A painter lost in the stroke of color, a runner who feels the road blur beneath their feet, a musician who becomes the song. In these moments, the internal clock fades, the mind stops measuring, and the body moves as one continuous present. But in moments of fear or anxiety, the opposite occurs. The brain records more information per second, as though trying to preserve every detail in case survival depends on it. Later, when recalling the event, it feels as though time slowed down. It never did. Perception simply expanded, capturing more frames in the same span. Joy, too, has its own effect. Excitement makes time feel faster, because the brain's inner pulses quicken, matching the rush of adrenaline. Anticipation does the same. It accelerates the mind's counting mechanism, making moments slip through the fingers like sand. Memory density, however, tells another story. When we experience something new, a trip to an unfamiliar city, the first day of a new job, the first time we fall in love, the mind records countless details. The memory becomes thick and vivid, and when we look back, that day feels long and full. Routine days, by contrast, are sparse. They slide away unnoticed, creating the illusion that the years move faster as we grow older. The brain, clever but economical, compresses sameness to save space. Childhood, therefore, feels long because it is rich with novelty, and adulthood seems shorter because its hours repeat. Culture shapes our experience of time as well. Languages build metaphors that quietly train our sense of its direction and meaning. In English, time is a resource, something to be saved, spent, or wasted. In Aymara, an indigenous language of South America, the future is said to lie behind us, unseen and unknowable, while the past is ahead, visible and remembered. Such metaphors remind us that the feeling of time is not universal. It is shaped by imagination, habit, and the stories we tell ourselves about movement and change. Even the body keeps its own measure. It listens to rhythm through the pulse, through cycles of sleep and wakefulness, hunger and rest. When we are idle, areas of the brain, tied to internal awareness, grow louder, like drummers tapping impatiently. The beats multiply, and the brain mistakes the surplus for longer duration. When attention finds focus, those beats fade. Time softens, stretches thin, becomes a single flowing moment. The difference between impatience and immersion is not in the clock, but in the pattern of our awareness. Memory, too, bends time's flow. The way we recall an event changes its length in the mind. A single afternoon can feel eternal when remembered in vivid color, or it can vanish completely if left unmarked. When you look back on the past year, you are not seeing time as it was. You are seeing it through the density of experience stored in memory. To make time feel fuller, we need only notice more. Attention is the artist, and time is the canvas. Science offers subtle proof of these illusions. Take the return trip effect. The feeling that the way home is shorter than the way there. Both journeys are identical in distance and duration, but the first demands curiosity, the second familiarity. The brain spends more effort processing novelty than routine, so the outward trip seems to last longer. The same happens with the famous snooze button illusion. Those brief minutes of half sleep between alarms feel weightless because the brain drifts between consciousness and dream, where time has no edges. Even modern neuroscience hints that our sense of time is tied to chemistry. Dopamine, the neurotransmitter of reward and motivation, can speed or slow our internal rhythm. When dopamine levels rise, as they do with anticipation, excitement, or creativity, the mind's metronome ticks faster and moments seem shorter. When dopamine falls, time expands like a sigh. Our emotions are, in a sense, biological clocks that reshape our world from within. So when we say time flies, what we really mean is that we are alive, that attention is flowing freely, unmeasured, unbroken. And when time drags, it's not that the world has slowed, but that we have become aware of its machinery. The feeling of duration is born from consciousness itself, from the gap between noticing and forgetting. Before humankind ever built sundials or divided hours, this inner clock was already ticking. Long before civilizations carved calendars into stone, our ancestors watched the fading of firelight and felt the rhythm of heartbeat and breath. They sensed what we still feel, that one moment becomes another, that change never ceases, that even in silence, something is always moving. Time began as awareness, as the recognition of difference between now and then, between the pulse of life and the stillness that surrounds it. The beauty of it all is that time as we live it is not an enemy or a thief. It is a companion. It gives texture to existence, a rhythm to thought and meaning to movement. It can hurt, yes, when moments end too soon, but it can also heal, carrying us gently from sorrow toward understanding. Time is not measured only by what happens, but by how deeply we feel it. And so, before we look to the stars and the heavens, before we measure seconds with precision, we begin here, in the soft architecture of the mind. This is where time first learned to breathe, where it took on the shape of memory and heartbeat. Every second you live is not merely counted, but created, sculpted by perception into something uniquely your own. And while our minds shape the flow of time, our ancestors once looked upward to the patterns of light and shadow, to the long journeys of the sun and moon. They reached beyond themselves and carved time into the sky. Long before the hum of machines, before pendulums swayed and seconds were born, time was measured by light. The first humans did not own clocks. Yet they lived by a rhythm more precise than any invention, the turning of Earth beneath the Sunday. To them, each sunrise was a renewal, and each sunset a soft surrender. Shadows, lengthened winds, shifted, and the constellations drifted across the black canvas above. The sky became the first teacher, and light its patient language. Picture the early world. The dawn mist, lifting over rivers, birds, stirring the horizon painted gold. Somewhere, a hunter notices how the morning light crawls along the same branch each day before he leaves to follow the herds. A gatherer senses that certain stars return with the ripening of fruit. Without numbers or words for hours, they already understood something profound, that time moves in patterns and the world keeps count for those who learn to watch. Millennia, later in the heart of ancient Egypt, that same awareness rose into stone. Tall obelisks pierced the desert sky, their shadows sweeping slowly over the sand. Priests traced those shadows across carved lines, marking the day's passage in sunlight. Around 1500 years before the Common Era, the Egyptians created one of the earliest sundials, dividing daylight into 12 parts, not equal by the clock's standard, but equal by the sun's grace. Their hours stretched long in summer and grew short in winter, breathing with the rhythm of the seasons. When darkness fell and the shadows vanished, time did not stop. Water took over where sunlight left off. The Egyptians built water clocks, or clepsydra bowls of stone or bronze, with a tiny hole at the bottom, letting water drip out at a steady pace. The Greeks and Chinese later refined them, adding scales and markings to measure the hours of night. The drip of each drop echoed softly in temple halls, a liquid heartbeat of passing time. In this gentle flow, we hear the origins of modern timekeeping, not mechanical, but elemental. Elsewhere, beneath other skies, humans found their own ways to listen. In what is now England, the great stones of Stonehenge rose like teeth against the horizon. For centuries, it was thought to be a tomb, a monument, a mystery. But we now know those stones are aligned with the solstices, a vast prehistoric calendar marking the longest and shortest days of the year. When the midsummer sun rises precisely over the heel stone, light floods through the circle, casting a line of brilliance across the altar. The people who built it may not have known the word astronomy, but they knew the dance of the heavens. Far across the ocean, in the dense forests of Central America, the Maya gazed upward too. They watched the path of Venus, the moon's phases, and the shifting seasons with such accuracy that they predicted eclipses centuries in advance. Their long count calendar, carved into stone, spanned more than 5,000 years. To them, time was not linear but cyclical, a circle, not an arrow. Every ending was a beginning, every death a renewal. The sun's rising and setting, the rain's return, the birth of crops, all were part of an infinite cycle where life and time folded endlessly into each other. In Mesopotamia, the Babylonians carved a different kind of legacy. They divided the circle into 360 degrees. And from their mathematics came the structure that still rules our clocks today. 60 minutes in an hour, 60 seconds in a minute. Their base 60 system became the silent skeleton of time, a numerical rhythm that transcended empires. Every time we look at a watch or map, we're using their inheritance, a gift from an ancient, sky-watching culture that sought order in the chaos of stars. To the east in China, astronomers built towers topped with great bronze armillary spheres, mapping the heavens with delicate precision. Around 1,000 years before the Common Era, they created advanced water clocks that not only measured hours, but predicted planetary alignments. In these instruments of dripping water and turning wheels, time began to take shape as both science and art. Each improvement wasn't born of impatience, but of reverence, an attempt to synchronize human life with the grand pulse of the universe. Through all these ages and empires, one truth echoed. The act of measuring time was not about domination, but connection. Every calendar, every sundial, every carved shadow line was an act of faith. Faith that the cosmos was ordered, that light would return, that tomorrow would resemble today. To track time was to believe in the world's continuity. Imagine for a moment the sound of an ancient temple at dawn, priests murmuring in low voices as the first rays of sunlight creep along a wall. A shadow touches a mark, and incense smoke drifts upward. A bell rings. Somewhere in the stillness, the human spirit learns that waiting, watching, and measuring are forms of prayer. The beauty of these early clocks lies not in precision, but in patience. They were not designed to command time, but to honor it. Every civilization's tool was an expression of wonder. The Egyptians sculpted sunlight, the Chinese sculpted water, the Maya sculpted stone. In each we glimpse a universal desire to know where we stand in the great unfolding of existence. As centuries passed, this devotion to celestial rhythm deepened. In medieval Europe, monks began to divide their days by the tolling of bells. The word hour itself comes from hora, the sacred divisions of prayer. To live by the hour was to live by devotion. The sound of bells, rolling across valleys at dawn and dusk, marked not just the passage of time, but the pulse of faith. The first mechanical clocks appeared in monasteries and towers, their gears turning with the same purpose to remind humanity when to pause, reflect, and begin again. And yet something subtle began to shift. As timekeeping grew more accurate, its purpose expanded from worship to work. Bells that once called to prayer began to regulate labor. Clocks left churches and entered cities. Time became both discipline and power, a silent ruler over markets, schedules, and trade. Still, its roots in the sky remained. Every tick still echoed, from a shadow once traced across stone. It is remarkable to consider that all these inventions, from dripping bowls to ringing bells, were inspired by the same celestial pattern, the Earth's rotation completing one spin every 24 hours, the Moon's orbit waxing and waning every 29.5 days, the Earth's path around the Sun marking a year of change and return. Even now, our most advanced atomic clocks must adjust for the planet's tiny irregularities, a reminder that the sky still sets the ultimate rhythm. The great thread of timekeeping stretches unbroken from those first obelisks to today's satellites. Ancient astronomers used the stars to align temples. Modern engineers use them to align signals. The principle has not changed, only the instruments have. The pulse that began in light now beats in circuits and atomic oscillations. But its essence remains the same: to find harmony between the human and the cosmic. So when we look at our modern clocks, those glowing digits counting down to appointments and deadlines, we are not separate from the ancients. Their wonder lives in us. Each moment, we glance at the time, we reenact an ancient ritual, seeking to understand the eternal through the ordinary. Timekeeping was, and still is, humanity's most enduring collaboration with the universe. It is the poetry of attention turned into science, the art of noticing change, of trusting the sun will rise again. The Egyptians trusted the shadow, the Maya trusted the cycle, the Babylonians trusted the number, the monks trusted the bell, and we today trust the pulse of an atom, unseen yet utterly faithful. If you listen closely, the story of human timekeeping hums like a song, each verse written in a different age. A stone shadow sings the first note. Water follows with its dripping rhythm, and bells add harmony. Then come gears and pendulums, quartz vibrations, and atomic whispers, each generation tuning the melody of time a little closer to perfection. But perfection is never the point. What matters is the connection, the line of wonder stretching from the first sunrise to this very second. The clock is not our master. It is our mirror, reflecting the patience of creation. Every dial, every gear, every glowing screen is a continuation of an ancient gesture, humanity looking up and whispering, "How long?" As the chapter closes, the sky that once taught us to measure now watches silently as our machines count the seconds without us. Yet somewhere in that quiet, ticking the echo of the old world, remains the slow drift of shadow, the soft fall of water, the turning of stars. The same universe that taught the ancients to listen still speaks to us now, though its language has changed. For all our modern precision, we remain children of the sky, learning, again and again, how to tell time by the light that touches us. When the 17th century dawned, humanity was already fluent in the language of the sky. We had measured the rhythm of day and night, charted the paths of stars, and divided life into minutes and hours. Yet something new began to stir a question, not only of when things happened, but why. The sky was no longer just a calendar of light. It became a puzzle of motion. And in the hands of one man, Isaac Newton, that puzzle would be solved with elegance so profound that it would define our understanding of time for centuries to come. The story begins in silence, an apple falling through the air. Whether the tale is myth or truth hardly matters, because what it represents is real. A moment of clarity, when gravity ceased to be a mystery of divine whim and became a law of nature. Newton looked at that fall and saw a pattern. The same force that pulled the apple toward the ground was the one that guided the moon across the night sky. Suddenly, the universe was not chaos, but choreography, each motion bound by rules that could be written, measured, and predicted. To Newton, time itself was part of that structure. He saw it as absolute, unchanging, flowing steadily like an invisible river beneath all motion. In his Principia Mathematica, published in 1687, he described it simply absolute, true, and mathematical time of itself, and from its own nature, flows equably, without regard to anything external. It was a radical certainty, a belief that time ticked the same everywhere, always, no matter what happened within it. In this vision, the universe became a perfect machine. Every planet's orbit, every falling stone, every swing of a pendulum could be traced back to mathematical precision. Space and time were the great stage upon which existence played out, and the laws of physics were the script. For the first time, humanity could describe the universe not as myth, but as mechanism. It was a comforting image, a cosmos ruled by order, not chaos, by logic, not chance. The stars were no longer gods, but gears turning in the grand design of creation. Newton's equations could predict eclipses, tides, and the motion of comets. The universe had rhythm, not mystical but mechanical, and that rhythm became the heartbeat of the Enlightenment. In the echo of that discovery, the world changed. The same precision that defined celestial motion began to shape human invention. Engineers built clocks that mirrored the predictability of the heavens. Cities began to live by regular schedules, factories by regulated hours. The human mind, once humbled before the mystery of time, began to believe it could master it. The ticking of clocks became not only a measure of the day, but a metaphor for the new age. of reason. But even as Newton's universe grew orderly, it also became strangely cold. If everything was determined by motion and law, where was the place for chance, for will, for wonder? The philosopher Gottfried Wilhelm Leibniz, a contemporary of Newton's, saw this problem clearly. He argued that time was not a container through which the universe moved, but a relationship between events, a measure of change itself. To Leibniz, time without change was meaningless. He asked, if nothing happens, what is the passage of time? This debate between Newton's absolute time and Leibniz's relational time became one of the great philosophical tensions of science. Newton's world was clean, mathematical, predictable. Leibniz's was dynamic, woven from connection and perception. And though Newton's version would dominate for centuries, Leibniz's whisper of doubt would later echo in Einstein's revolution. For now, however, the world basked in the symmetry of Newton's creation. His laws made sense of falling bodies and spinning planets alike. The solar system became a clock of perfect regularity, each planet an obedient gear. The discovery of gravity unified heaven and earth under one principle, erasing the divide between the divine and the physical. The same force that shaped the tides shaped destiny itself. Across Europe, thinkers began to imagine reality as a vast, predictable engine. Painters sketched geometric order into their art. Composers like Bach wrote music with mathematical symmetry, fugues unfolding with mechanical grace. Philosophers argued that even the mind was part of this great design, that reason, like gravity, was a universal law. The harmony of the spheres had become the harmony of mathematics, and yet, in this precision, a subtle melancholy lingered. If everything was determined, if the universe ran like clockwork, then what of free will? What of unpredictability or miracles or dreams? If time was a river that flowed regardless of us, were we not merely passengers for all its beauty? Newton's universe carried the quiet weight of inevitability. Still, it offered humanity something precious, the ability to predict, to see ahead, to calculate the future from the present. Farmers used Newton's principles to time their harvests with the planets. Sailors charted safer voyages with the stars. Builders designed cathedrals whose arches obeyed the same laws as falling apples. Time, once mystical, became practical, the cornerstone of engineering and discovery. As pendulum clocks began to tick across Europe, the metaphor of the universe as a clock took hold. Clockmakers and astronomers worked side by side, refining accuracy to astonishing degrees. The most famous of these was Christian Huygens, who had invented the pendulum clock only decades before Newton's work. His designs, swinging in perfect arcs, were both instruments and symbols, human attempts to mirror the precision of the cosmos itself. And so the Enlightenment world became synchronized, both literally and philosophically. The regularity of time promised progress. It gave rhythm to thought, order to life, and reason to faith. The chaos of the medieval night was replaced by a new morning of light, intellect, and calculation. To know time was to know truth. But beneath the calm ticking of that era, questions stirred faint at first, then growing louder. Could time truly be absolute, unbending, universal? Did it really flow the same for a mountain, and a valley for a star, and a falling stone for a thought, and a breath? Newton's river seemed smooth, but deep within new currents began to bend, swirl. As centuries passed, the precision that Newton imagined began to reveal its cracks. Astronomers noticed small discrepancies in planetary motion that the laws of gravity could not fully explain. Philosophers began to doubt whether an absolute now could exist at all. And as humanity's instruments reached farther into the cosmos light itself, the messenger between stars, began to behave in ways Newton's universe could not predict. Still, for over 200 years, Newton's framework reigned supreme. It guided the Industrial Revolution, the age of discovery, the birth of modern science. It built bridges and observatories, engines and empires. His equations became the scaffolding of civilization. But quietly waiting at the edge of this perfection was a young man in Bern who would one day ask the question that undid it all. What if time itself can stretch? Before that moment came, though Newton's vision left humanity with a legacy, the belief that nature is knowable, that order can be found even in chaos. His universe may have been mechanical, but it was also deeply human, born of our desire to make sense of the infinite. Every clock that ticked in the centuries after him carried the echo of that desire, the yearning to find peace in predictability, meaning in motion, eternity in measurement. When you stand beneath a clear night sky, the stars do not seem to move, yet they are in constant motion, governed by the same equations that shaped Newton's thoughts. Somewhere out there, the planets still circle in obedience, keeping time with invisible precision. To watch them is to see his genius alive, the poetry of gravity written across the dark. But time, as it turns out, would not remain so obedient. The universe, once imagined as a perfect clock, was about to reveal its flexibility, its strangeness, its soft and surprising bend. Another mind would take the rigid gears of Newton's cosmos and let them drift, curve, and stretch through spacetime itself. By the dawn of the 20th century, Newton's universe had become our trusted map of reality. Elegant, predictable, eternal. Space was a stage time, a metronome, and everything that moved obeyed the same invisible rhythm. For over 200 years, his equations had explained the orbits of planets, the flight of cannonballs, the rise and fall of tides. It was a cosmos of perfect order, one that made sense. Yet somewhere within that perfection, something didn't fit. Light itself, that elusive traveler between worlds, refused to play by Newton's rules. In laboratories and observatories, scientists noticed that no matter how fast you moved toward or away from it, light always raced by at the same unchanging speed. It didn't matter if you were chasing it or watching it retreat. It was constant, absolute, indifferent to everything. This defied common sense. In Newton's world, if you ran toward a moving object, it should meet you faster. But light, that most ancient of messengers, did not bend to expectation. It followed a deeper order, one waiting to be uncovered. Enter Albert Einstein, a young patent clerk in Bern, Switzerland, who saw the cracks in Newton's clockwork and quietly began to rebuild the universe from scratch. He was 26 when he published his paper on special relativity in 1905. And in doing so, he forever changed the way we see time. Einstein asked a simple but daring question. What if time itself depends on how you move? In his new vision, there was no single universal now. Two people moving at different speeds could disagree on when an event occurred, and both could be right. Space and time, once separate in Newton's equations, fused into a single, seamless fabric space-time. And in this fabric, motion could stretch or compress the flow of time. The faster you travel, the slower your clock ticks compared to one at rest. This was no philosophical speculation. It was a measurable physical truth. If you could board a spacecraft and approach, the speed of light, time for you would begin to slow. Your heartbeat, your thoughts, your entire being would stretch across space-time. Days for you could pass as centuries for those left behind. This is time dilation, one of Einstein's most astonishing discoveries. Imagine twins born on Earth. One remains home, while the other sets off in a ship that sails close to the speed of light. When the traveler finally returns, their sibling has aged decades while they have aged only a few years. It sounds like fantasy, but it's been proven in the smallest and most precise of ways with atomic clocks flown on airplanes. When the clocks returned, they showed exactly what Einstein had predicted. Time had slowed for the travelers. The cosmos, it seems, keeps its own peculiar schedule. But Einstein wasn't finished bending the rules of reality. A decade later, he expanded his ideas into what became known as general relativity, a theory that did more than stretch time. It revealed how gravity shapes it. According to Einstein, gravity is not a force pulling objects together as Newton had imagined, but the curvature of space-time itself. Picture a heavy ball resting on a soft rubber sheet. The surface curves around it. Now, roll a smaller ball nearby, and it spirals inward along that curve. That's gravity, not an invisible tug, but the bending of the very fabric of reality. This bending does more than guide motion. It also warps time. The stronger the gravity, the slower time passes. Near a massive object, say a black hole, time itself stretches thin, like a slow, viscous current of honey. Stand close enough, and a minute, for you could equal years for someone far away. We've tested this too here on Earth. In one experiment, scientists placed two identical atomic clocks at different altitudes, one at the top of a tower, the other near the ground. The lower clock sitting deeper in Earth's gravity, well ticked ever so slightly slower. Even your own body experiences this difference. Your feet are, in a sense, younger than your head. The effect is unimaginably small, but it's real. The universe Einstein showed us does not run on a single, steady rhythm. It pulses differently in every corner, every velocity, every gravity well. There is no master clock in the heavens, only local rhythms, woven together like threads of a vast living tapestry. And though we may not feel it in daily life, this warping of time underpins our modern world. Every time you open a map on your phone or use GPS, you are relying on Einstein's equations. The satellites orbiting Earth experience less gravity and greater speed than we do on the surface, which makes their time run faster. Engineers must constantly correct this difference. Otherwise, your position on the map would drift miles off course within minutes. Even in the most ordinary moment, relativity hums quietly beneath your footsteps. It is humbling to realize that time, the thing we thought most reliable, is not absolute. It bends, flexes, and stretches like a cosmic fabric adjusting itself to motion and mass. What we call now is not universal, but personal, a local arrangement between observer and light. Time, Einstein taught us, is stitched inseparably into space, and together they form the stage upon which all existence unfolds. This discovery did more than change physics. It changed philosophy. For if time is relative, what becomes of the past and the future? Are they truly gone or yet to come? Or are they simply coordinates in space-time, as real as the present, just viewed from a different angle to Einstein? The distinction between past, present, and future was a stubbornly persistent illusion. And yet, what an exquisite illusion it is. Imagine the universe as a grand quilt of moments, every heartbeat, every sunrise, every memory existing together in an eternal pattern. We move through this pattern, not because time flows, but because we do, tracing our own path through the geometry of existence. Each of us, in a sense, is a traveler of space-time, carried by the curvature of reality itself. Even light, the fastest thing there is is bound by this fabric. Its path curves around stars and galaxies, a phenomenon known as gravitational lensing. To distant observers, starlight bends gracefully around massive objects, painting rings of light in the darkness. Proof that space and time are not rigid, but alive, responding to every presence and every mass. Einstein's equations predicted this long before it was seen, and when starlight, during a solar eclipse in 1919, confirmed his theory, the world awoke to a new universe, one of elasticity and wonder. The clockwork cosmos had softened. The rigid machine had become a flowing fabric, vibrant and mysterious. And yet, for all its strangeness, Einstein's universe feels strangely human. It is flexible, emotional, almost responding to presence and pressure, stretching under weight and light alike. Time is no longer a ruler. It is a companion different for each traveler, each star, each heartbeat. If Newton's universe was a symphony of precision, Einstein's is a slow waltz of relativity. There are no absolutes, only relationships. Motion defines time, gravity sculpts it, and the observer, the humble witness, completes the equation. So the next time you glance at the stars, remember their light began its journey long before you were born. But in the fabric of space-time, that journey and your gaze are part of the same eternal geometry. The cosmos does not keep time as we do. It simply is a vast and breathing continuum of moments. Einstein once said that, for those who understand relativity, the separation between past, present, and future is an illusion. Perhaps that's the gentlest comfort science has ever given us, that nothing truly leaves, nothing is truly lost, and that in some quiet corner of space-time, every moment we've ever lived still glows. If Einstein showed us that time can bend, twist, and slow, another mystery still flowed beneath it all, one that no geometry or equation could quiet. Even though time flexes differently for each observer, it always moves in the same direction. No matter how gently we plead, no matter how precisely we measure, the seconds we live never flow backward. A glass once broken will not mend itself. A flame once extinguished does not reignite on its own. And a life once lived, however vividly, cannot be replayed except in memory. Why? What gives time its unrelenting direction, its arrow, pointing only forward? The physicists call this mystery, the arrow of time, and its origin lies in one of nature's deepest principles, entropy, the gradual drift of the universe toward disorder. It is the quiet law that governs everything from the cooling of a cup of tea to the collapse of stars. Entropy is not chaos, but the measure of how many ways something can exist. A neat arrangement of atoms, a crystal, a flame, a heartbeat has low entropy. The moment it breaks down, spreads out or fades, its entropy rises. The second law of thermodynamics tells us that in a closed system, entropy always increases. The universe, as far as we can tell, is such a system, and so time must always move forward. Picture a single ice cube melting on a warm table. Its molecules, once locked in a perfect lattice, begin to move freely, scattering into disorder. The energy that held it still seeps into the air. The process feels natural, inevitable. But now imagine the reverse: scattered droplets of water leaping back into a cube, heat flowing neatly back into the room, the past unspooling before your eyes. The laws of motion wouldn't forbid it. Newton's equations work just as well backward, but the probability is infinitesimal. The universe favors disorder because there are infinitely more ways for things to be disordered than arranged. And so, the arrow of time is not written in mathematics, but in statistics, in probability. It is not that the universe cannot run backward, it simply will not. Every broken cup, every puff of smoke, every faded echo of laughter adds to the growing tapestry of entropy, the cosmic proof that time moves only one way. The human heart feels this law instinctively. We sense it in the irreversibility of a goodbye, in the way music fades rather than begins again, in the way childhood never repeats. Entropy is the quiet undertone of existence, whispering that everything changes, that nothing stays perfectly arranged for long. And yet, this forward motion, this inevitable drift is not a curse, but a rhythm. Without it, there would be no growth, no evolution, no story to tell. Physicists often imagine the universe's timeline as a grand experiment in entropy. At its beginning, just after the Big Bang, everything was astonishingly smooth. Energy evenly spread, matter distributed almost perfectly. Low entropy. Then over billions of years, tiny fluctuations began to form slight irregularities in that early cosmic soup. Gravity pulled matter together into clouds, then into stars, then into galaxies. Paradoxically, those bright points of structure, the very symbols of order, were born from the increase of entropy. Stars shine because they release energy, pushing the universe ever further along its one-way flow. Every sunrise, every ocean wave, every gust of wind is part of this grand unfolding. The arrow of time points forward because energy moves from concentrated to diffuse, from flame to ash, from heartbeat to stillness. The cosmos itself is a river, and we are carried upon its current. But what if in some far distant future, entropy reaches its end, when all stars have burned out, when every atom has settled into uniform stillness, when there is no gradient left to drive motion or thought? Physicists call this the heat death of the universe, a horizon of absolute equilibrium where nothing changes, and thus time ceases to have meaning. In that distant silence, perhaps time itself will finally stop flowing. The river will empty into its ocean. Yet we are far from that. The universe for now still dances between order and chaos. Galaxies collide, stars are born, and life, improbably organized, defiantly complex, rises from the entropy around it. Life, in fact, is the great rebellion against disorder. Every living cell, every heartbeat is a small act of defiance, borrowing energy from the environment to build structure, to maintain form, to create meaning, before dissolving again into the larger flow. We too are temporary pockets of low entropy, fleeting shapes within the stream. Our memories, our stories, our civilizations, all exist because of this imbalance, this gentle asymmetry of energy. Without it, nothing could begin, change, or end. Without entropy, there would be no time at all. There's a quiet beauty in that truth. The same principle that ensures a glass will shatter, that seasons will turn, that stars will die, is also what allows us to live, love, and remember. Entropy gives time its direction, and that direction gives life its meaning. We move forward not because we must, but because forward is where creation happens. Think of it. When we look back, we see a path carved by entropy, a trail of transformations. The melting ice, the fading echo, the waning sun, all reminders that existence is motion toward dispersal. And yet, from this inevitable scattering comes wonder, because to witness time's arrow is to witness the act of becoming. Even our sense of memory is shaped by entropy. We remember the past because it left traces, ordered imprints in our neurons, marks of energy and change. The future leaves no such traces. It's unwritten, unrecorded, undefined. Thus, the mind itself becomes an instrument of the second law, a living witness to the universe's unfolding. We know where we've been, because the past is preserved in patterns. We cannot see ahead, because the patterns have not yet formed. The arrow of time is therefore both cosmic and deeply personal. It governs galaxies and heartbreaks alike. The same law that cools a dying star also fades the color of a childhood photograph. It reminds us tenderly that nothing is permanent, that beauty is made more sacred by its impermanence. Entropy gives us the bittersweet awareness that every sunset is unique, that every fleeting joy is unrepeatable, and that the universe's motion forward is not destruction, but evolution. The great ongoing transformation of energy into story. And yet in this forward-only flow, there is peace. To know that we cannot go back is to be freed from trying. Time's current carries us, yes, but it also holds us. It assures us that even in loss, something endures the pattern, the memory, the continuity of motion itself. The universe moves forward because it cannot do otherwise. Stars burn because they must. Ice melts because it is warmed. And we breathe because the arrow of time gives us both a beginning and an end. And in between a chance to be aware. So when you watch a candle flicker, know that you are witnessing entropy made visible order, dissolving into glow structure, surrendering to warmth. But also know that in that act, something miraculous happens. The candle, though it fades, gives light an echo of the universe itself, always transforming, always creating. Even as it moves toward rest. Entropy is not the enemy of beauty. It is beauty the reminder that every moment's perfection lies in its passing. If the arrow of time gives the universe its steady direction, the quantum world laughs softly at the very idea of direction at all. Down there, in the realm of atoms and probabilities, time behaves less like a river and more like a mist, drifting reversible and often indifferent to the rules we hold dear. The deeper we peer into the subatomic, the less time seems to flow. It wavers, hesitates, and sometimes disappears entirely. Imagine the smallest scales of reality: electrons flickering around a nucleus, photons blinking in and out of existence, quarks dancing in endless vibration. In this invisible realm, nothing stands still long enough to call now. Particles can exist in many states at once, both here and not here, both spinning and not spinning, until the act of observation crystallizes them into certainty. Time in this domain does not march. It shivers. It hums softly in probabilities. The great Austrian physicist Erwin Schrödinger gave us the equation that defines this delicate dance. The Schrödinger equation, a mathematical poem describing how a system's wave of probability evolves. It tells us that all particles are not single points, but waves of possibility stretching through time and space until something, an interaction, a measurement, a gaze, collapses them into a single outcome. But here's the quiet riddle. The equation itself does not require time to move forward. It works just as well backward. The arrow we cling to in our everyday world begins to blur. In classical physics, you could always rewind a moment, drop a ball, watch it bounce, then imagine it in reverse. Perfectly plausible. In quantum physics, however, the act of observing, of simply knowing, changes the event. Reality is not merely unfolding. It is being woven in real time, by observation. The universe, it seems, is participatory. It doesn't simply exist, it responds. This is where time begins to lose its shape. In the quantum realm, time is often treated as an external parameter, a silent metronome outside the system, ticking evenly as the wave functions shift. But when physicists attempt to merge quantum theory with Einstein's general relativity to describe not just particles, but the entire universe, time vanishes from the equations altogether. One of those haunting equations is the Wheeler-DeWitt equation, named after physicists John Wheeler and Bryce DeWitt. It describes the quantum state of the entire cosmos, every field, every particle, every possible configuration, and astonishingly, there's no time variable in it. None. The universe, according to this equation, does not evolve. It simply is a vast, static sea of possibilities, where everything that could happen already exists. There is no before, no after, no flow, only a great and timeless now. To our human minds built to count seconds and remember moments, this is almost impossible to grasp. How can there be motion without time, change, without sequence existence, without duration? Some physicists like Julian Barber suggest that what we experience as time is an illusion born from patterns of change. The universe, he argues, is made up of countless nows, snapshots of reality, each complete and eternal. Our consciousness strings them together, giving us the illusion of flow. We are, in his words, time-blind fish, swimming through a timeless sea. It's a beautiful thought, unsettling, but poetic. If Barber is right, then every moment we've ever lived still exists, forever preserved as one of the infinite nows. The laughter of a childhood afternoon, the breath of a loved one, the quiet of tonight, all fixed, all real. Time does not carry us away. It reveals us one frame at a time. Others look for time's origin, not in our perception, but in entanglement, the mysterious connection between particles that allows them to influence each other instantly, even when separated by light years. Some physicists believe that the arrow of time, and perhaps time itself, emerges from the growth of these quantum connections. As the universe evolves, it becomes more entangled, more correlated, more intertwined. And this increase in entanglement may create the illusion of temporal flow. In other words, time might be nothing more than the expanding web of relationships between things. Quantum theory also gives rise to perhaps the most haunting of all interpretations, the many worlds interpretation. In this view, every quantum event, every flicker of uncertainty, splits reality into countless branches. Each possibility exists in its own universe, coexisting with all others. In one world, a photon passes through a slit. In another, it does not. In one, you pause to listen to this story. In another, you do not. Time in this model is not a line or a river, but a vast, branching forest, infinite, intricate, and alive with possibility. To live within such a vision is to exist in a fog of wonder. The future is not waiting. It is blooming in every direction at once. The past is not gone. It's still unfolding in another branch of reality. And we delicate observers walk our narrow path through this quantum garden, aware of only one trail, while infinite others shimmer just beyond perception. Still, for all its mystery, the quantum world remains astonishingly practical. Every time you use a computer chip, a laser, or a magnetic resonance scanner, you are relying on the rules of quantum mechanics, the same strange dance of probabilities that questions the nature of time itself. The uncertainty that seems abstract in theory becomes tangible in the glow of your screen. in the hum of every atom around you. Even more curious is that quantum theory has restored something that Newton's mechanics took away: a touch of unpredictability, a whisper of freedom. In the mechanical universe, everything was determined. In the quantum world, the future is not fixed. It is a cloud of potential, collapsing only when chosen, observed, realized. Perhaps in a poetic way, time itself is created by our participation in it. The act of noticing, of existing. When viewed this way, the quantum haze isn't a contradiction of time, but its origin story. Time as we feel it might be the slow unfolding of probability, the steady crystallization of what could be into what is. Each heartbeat, each breath, each flicker of thought is a choice among infinite paths, and together they write the narrative we call the present. And so at the smallest scales, time becomes not a straight road, but a misty horizon where beginnings and endings blur, and everything particle, person, universe exists as both potential and reality. In that haze, perhaps there is a quiet comfort, because if time can vanish and reappear, then maybe everything that ever was, every kindness, every song, every dream, still lingers somewhere in the fabric of possibility. To think of time in this way is not to lose it, but to soften its edges. In the quantum haze, the rigid ticking of clocks dissolves into a shimmering continuum, where motion and stillness are the same melody played at different tempos. It's strange, it's beautiful, and it reminds us that beneath all our measurements, the universe is still whispering mysteries, timeless, weightless, and endlessly becoming. After drifting through the mist of the quantum world, where time dissolves into possibility, we return home to the warm, breathing rhythm of life itself. Here, time is not a distant theory, but something lived, felt, embodied. Every heartbeat, every breath, every blink of an eye marks the passing of an invisible rhythm that our cells have kept since the dawn of life. We carry within us the memory of sunrise and sunset of the turning earth. The universe may count time in stars and entropy, but we, its living children, count it in pulses and dreams. Each of us is born into a world already in motion. Even before our first breath, our bodies have begun their quiet synchronization with the cycles of light and dark. Deep within our brains, nestled in the hypothalamus, lies a tiny cluster of about 20,000 neurons called the suprachiasmatic nucleus, or SCN, the master clock of the human body. This small knot of tissue, no larger than a grain of rice, governs the rhythm of our days. It listens to the light that enters our eyes each morning, translating photons into timing instructions for our cells. Through this luminous dialogue, the body learns what time it is. The SCN sends its signals outward, orchestrating a vast symphony of biological clocks. Every organ, heart, liver, lungs, skin, keeps its own rhythm. A molecular pulse, known as a circadian rhythm. Circadian comes from the Latin circa diem, meaning around a day. Each of our cells contains its own molecular gears and switches that tick with astonishing precision, guiding sleep and wakefulness, hunger and metabolism, alertness and rest. Together, these cellular clocks form a planetary chorus of life, singing softly in synchrony with the rotation of Earth. When the sun rises, light travels through our retinas and reaches the SCN, signaling the suppression of melatonin, the hormone that brings sleep. As daylight strengthens, cortisol rises, preparing the body to wake, to think, to move. Temperature increases, blood pressure rises, and the metabolism begins to hum. By midday, the body reaches its peak of alertness, then gradually descends into evening calm. As darkness falls, melatonin returns, the heartbeat slows, and the body's warmth retreats toward its core. Every day we enact this quiet cycle, a biological sunrise and sunset, contained within our own skin. But our inner clocks are not fixed. They drift gently, seeking harmony with the world outside. Remove a person from all sunlight, and their rhythm will continue but slightly off. The cycle stretches to about 24.5 hours, proof that our internal timing is self-sustaining, yet yearning for calibration from the sky. Light, that ancient messenger, remains our truest guide. This connection to light and time is older than humanity. Even single-celled organisms, cyanobacteria, the ancestors of all green life, possess their own circadian mechanisms. They photosynthesize by day and rest by night, responding to sunlight as faithfully as a sunflower turns its face to the dawn. Across billions of years, this pattern has persisted, written into DNA like a cosmic refrain. The rotation of Earth became not just a planetary event, but a genetic inheritance. Plants, too, live by the clock. In forests and fields, petals open and close according to the sun's passage. Leaves fold at dusk, sap slows in the cool of night, and roots continue their quiet work beneath the soil. Even when kept in darkness, plants maintain their rhythm, as if remembering sunlight from within. This inner memory of day and night allows them to anticipate change, to bloom before dawn, to rest before dusk. An elegant ballet choreographed by time itself. Animals navigate by this rhythm as well. Migrating birds time their journeys, with seasonal shifts guided by daylight length. Sea turtles hatch on moonlit beaches and instinctively crawl toward the brightest horizon, the reflection of starlight upon the sea. In the Arctic, reindeer adjust their internal clocks to survive months of endless day and unbroken night. Time in nature is not abstract, but survival itself. And within us, time lives as emotion. We feel it as hunger, as fatigue, as longing. Our moods rise and fall, with the day's rhythm alert, in morning reflective by night. Disrupt that cycle, and the consequences ripple through every system. The modern world, with its glowing screens and sleepless cities, often confuses our ancient biology. Artificial light tells the brain it is still day-keeping melatonin at bay. The result is not only exhaustion but dissonance, a quiet mismatch between the world we built and the rhythm we were born to follow. Jet lag is a simple example of this internal discord. When we cross time zones, our body's clocks remain loyal to their old rhythm, even as the sky tells another story. It takes days for the symphony to retune for the SCN and its orchestra to find harmony again. Yet this recovery reminds us how persistent our inner clocks truly are, how deeply they are tied to the light of home. But the body's timing goes deeper still. There are ultradian rhythms, cycles shorter than a day, like the 90-minute waves of sleep, the patterns of heartbeat and breathing, the ebb and flow of attention. There are infradian rhythms, longer than a day, the lunar cycles that guide tides and fertility, the seasonal moods that mirror the Earth's own oscillations. We are not creatures of one rhythm, but many layered like harmonies in a song. When we rest, our hearts do not sleep. They slow, keeping perfect time. When we dream, our eyes dart behind closed lids in rhythm with imagined motion. Even the growth of hair and fingernails follows faint internal schedules. The entire body is a clock, a constellation of rhythms synchronized to the turning planet. In this realization lies a deep comfort that we are not apart from nature's time, but expressions of it. The same spin that carries the sun across the sky moves within us. The same cycles that govern the tides govern our breath. Every pulse we feel is the universe keeping time through us. Modern science has revealed astonishing detail in how these rhythms function. but the poetry remains the same as it was for the ancients. The Egyptian priests, who watched their shadows grow, the Chinese astronomers, who tracked water clocks, the Maya, who charted Venus, all sought to align with the same cosmic tempo that beats in our veins. Their monuments measured the sky. Our bodies measure it in flesh. Perhaps this is why moments in nature feel so grounding. To walk in morning light or sit beneath a full moon is to feel the resonance between the world and the self. To remember that our existence is not measured by devices, but by harmony. So as you listen to your breath now, know that it too follows a pattern as old as the earth. Inhale the rise of energy. Exhale the surrender to rest. The body expands, contracts, and repeats, a living mirror of the planets turning the universe's breathing. Time is not a thing we chase or measure. It is the pulse of life itself, always moving through us, never away. Even when we sleep, the clock continues, not as a reminder of loss, but as a song of renewal. Every cycle of rest repairs, restores, and prepares. Every dawn is both a continuation and a beginning. The universe keeps time through the rhythm of living things, and in that constancy there is peace. Time within the human mind is not a straight line. It is a breath, an illusion, a pulse of thought that expands and contracts according to emotion. We live inside a rhythm of our own creation. While the body measures time through light and hormones, the mind sculpts it through memory and awareness. To think is to travel through time, to linger in the past, to anticipate the future, and to drift between them as though they were rooms of the same vast house. Our perception of time is the most personal clock we own. It slows when we are bored, races when we are joyful, and fractures entirely in moments of fear. Scientists have long searched for the mechanisms behind this elasticity. The brain's prefrontal cortex and basal ganglia form part of an intricate system that tracks intervals and duration. But it is mood, attention, and experience that truly sculpt the flow. When we are present, deeply immersed in a task or a moment, time dissolves. When we are distant, distracted, or anxious, it drags like a heavy tide. Consider the way childhood summers seemed endless, the days spilling into one another like liquid sunlight. Then, as we age, years begin to collapse, blending into a rush of moments barely marked. Psychologists call this the proportional theory of time. Each year of life becomes a smaller fraction of our total experience, so time appears to accelerate as we grow older. The hours do not change, only our perception does. The mind's clock runs on memory, not minutes. Our memories themselves are not stored in sequence, but in layers, networks of feeling and detail. When you recall a moment vividly, your brain replays the pattern of activity that once occurred. For a heartbeat, the past becomes present again, and the boundary between then and now dissolves. Neuroscientists call this mental time travel, and it is one of the brain's most mysterious gifts. In the quiet theater of memory, you can step backward or forward through your life, replaying scenes, adjusting perspectives, even imagining alternate futures. You are, in essence, a time traveler of consciousness. But this power comes with consequence. The same mind that remembers can also worry, projecting forward into imagined disasters, rehearsing what has not yet happened. Anxiety is in many ways the side effect of a brain too fluent in time. We are creatures who can foresee, and that foresight often carries weight. Yet it also carries wonder. Hope, like fear, depends on the ability to imagine a future that does not yet exist. Time's burden and its beauty are one and the same. There are moments, however, when the mind slips free from time's grip, when seconds lose meaning and thought flows like water. Psychologists call this flow state, when attention becomes so complete that the self disappears and time with it. Musicians feel it when lost in sound. Artists when paint becomes motion. Runners when breath and stride align. It is the mind's version of timelessness, a brief reunion with eternity through focus and presence. Meditation, too, brings us close to this timeless space. In silence, when thought softens and breath steadies, the sense of before and after begins to fade. The brain's default mode network, which constructs the narrative of self and time, grows quiet. What remains is awareness pure, unmeasured, infinite in its stillness. The Buddhists call it samadhi, unity with the moment. In those rare instants, time does not move forward or back. It simply ceases to matter. But even outside meditation, we glimpse time's fragility. Grief stretches it into slow motion. Joy collapses it into flashes of brilliance. A single instant of love, terror, or awe can feel eternal. This is because the brain marks time through change, and powerful emotions saturate the senses, flooding the moment with significance. In heightened awareness, each detail is recorded. Each second elongated the color of light, the sound of breath, the texture of air. Time thickens when we feel deeply. Memory, however, is selective. It compresses and expands experience, turning weeks into impressions, years into fragments. What remains are not perfect records, but emotional contours, peaks of intensity, valleys of quiet. The brain edits, not maliciously, but mercifully preserving meaning rather than chronology. We do not remember every moment of our lives, only those that shaped who we became. In that way, time is woven through identity itself. We are the sum of what we recall and what we have yet to forget. Neuroscientists have found that the hippocampus, the part of the brain crucial for memory, acts almost like a clockmaker, linking events in sequence and anchoring them in context. Damage it, and time fractures. The past loses order, and the present stretches into a continuous now. To live without temporal memory is to live without story. And story, perhaps, is humanity's oldest way of measuring time, not in hours, but in meaning. We tell stories to understand the movement of our lives, beginnings, conflicts, resolutions, returns. The mind turns the endless flow of experience into a narrative arc, giving direction to what might otherwise feel chaotic. Without story, time would be an endless stream. With it, it becomes a journey. Each of us carries this hourglass of narrative inside the grains, falling not from future to past, but from experience to understanding. There is a tender irony in how our brains perceive duration. In the moment, attention slows time, awareness widens it. But in retrospect, the more attention we pay, the shorter the memory feels. A year filled with novelty seems long, while living it yet short when recalled. Familiarity compresses time, wonder expands it. The best way to lengthen a life, then, is not through years, but through curiosity. Each new experience stretches the canvas of perception, giving us more to remember, more to feel. Perhaps that is why the present moment feels so elusive. We reach for it, but it slips away, already becoming memory. And yet, paradoxically, the present is all we ever truly inhabit, a continuous arrival. Every thought, every heartbeat, every breath unfolds here, in this thin, luminous sliver of now. To live fully is to stop measuring, to let the grains of the hourglass fall without counting. Mindfulness, then, is not about slowing time, but about ceasing to chase it. To sit quietly and watch your thoughts rise and fade is to realize that they too obey a rhythm appearing, dissolving, replaced by the next. The mind's hourglass does not trap us. It reminds us that flow and stillness coexist. Time is not an enemy to conquer, but a companion to understand. As night deepens and the world quiets, awareness itself becomes the clock, the gentle pulse of consciousness, measuring not minutes, but presence. In that stillness, time opens wide. You are no longer moving through it, you are resting within it. The mind's hourglass stops, and for a breathless moment, eternity feels near. When you wake tomorrow, time will resume. Meetings, meals, minutes, motion. But something will have changed. You will remember, if only faintly, that the passing of time is not a loss, but a rhythm, that awareness is the space between grains of sand. Every moment you live fully becomes infinite in its own way. Since the first sunrise, humanity has watched time flow in one direction and wondered, what if it could be reversed? The idea that we might journey backward to see the world as it once was, or forward to glimpse what might yet be, has haunted our imagination for centuries. In myth, magic and science alike, time travel represents our longing to escape impermanence, to undo what cannot be undone, to touch eternity. Yet beneath the fantasy lies a deeper truth. Time travel, as impossible as it seems, reveals the very heart of how we understand reality. The dream began long before physics gave it words. Ancient storytellers spoke of gods and spirits, moving freely between eras, slipping through the fabric of destiny as easily as light passes through air. In Hindu mythology, Lord Vishnu's cosmic dance folded creation and destruction into a single repeating cycle. The universe reborn endlessly, time not linear, but circular. The Greeks imagined Kronos, the god of time, devouring his children, a symbol of time, consuming all things. Even then we sensed that to master time would be to transcend mortality. But science, in its quiet, disciplined way, eventually gave this yearning a language. When Einstein's theory of relativity revealed that time could stretch and bend, the dream of time travel became something more than myth. It became mathematics. The faster you move, Einstein showed, the slower your time flows. A traveler approaching the speed of light would experience minutes while centuries passed elsewhere. In this sense, the future is not unreachable. It is simply a matter of velocity. Time travel forward, paradoxically, is not fantasy at all. Astronauts orbiting Earth aboard the International Space Station experience time slightly slower than we do on the surface. They return home younger by fractions of a second. Minuscule, yes, but real. To travel backward, however, is another matter. For that, we must venture into the strange terrain of space-time itself, where gravity bends not only space, but chronology. Near a black hole where gravity is strongest, time slows dramatically. To an outside observer, an object falling toward the event horizon appears to freeze, never quite crossing the edge. From the traveler's perspective, however, time proceeds normally, but the universe beyond accelerates. The past, present, and future begin to lose distinction. Physicists have long speculated about structures known as wormholes, hypothetical tunnels connecting distant points in spacetime. These cosmic shortcuts, predicted by Einstein's equations, could in theory allow for time travel if one mouth of the wormhole experiences a different passage of time than the other. The concept ignites both imagination and paradox, for if one could step through and arrive before they left, could they prevent their own journey? This is the grandfather paradox, a thought experiment as old as modern physics itself. If you travel back and alter the past, do you erase the brand, conditions that allowed your travel in the first place? In the realm of science fiction, these contradictions are playgrounds for the mind. H.G. Wells in The Time Machine envisioned a device that could traverse the centuries like a ship sailing a temporal sea. Countless stories followed of portals, DeLoreans, wormholes, and quantum leaps, each one a mirror of our desire to rewrite, to revisit, to know. But the laws of physics for now seem to guard the timeline carefully. Time loops, or closed time-like curves, may be mathematically conceivable, but they come with impossible requirements. Energy densities greater than the mass of entire galaxies, exotic matter with negative pressure, and conditions that nature may never allow. And yet, even in the strictest equations, the dream refuses to die. Theoretical physicists such as Kip Thorne and Stephen Hawking explored the possibilities with both rigor and wonder. Hawking proposed the chronology protection conjecture, the idea that the universe itself forbids time paradoxes, sealing off any potential loops in spacetime before they can form. Time in this view protects its own consistency. But Thorne, ever the dreamer scientist, believed that under certain conditions, perhaps with quantum effects we do not yet understand, wormholes might one day become traversable. In his words, the laws of physics do not absolutely forbid time machines. Still, the paradoxes remind us that time is not merely a coordinate. It is causality itself, the logical chain linking events. To travel backward would be to break that chain, to untie the knot that holds existence together. If an effect could precede its cause, meaning itself might unravel. The arrow of time guided by entropy may be nature's safeguard, a guarantee that the story continues in one coherent direction. And yet, even without machines or wormholes, we already move through time in extraordinary ways. When we remember, we travel backward. When we imagine, we leap forward. The brain's ability to simulate the past and future allows us to rehearse, to learn, to create. In this sense, consciousness is the most advanced time machine ever built. Each dream, each recollection, is a journey through the corridors of subjective time. Perhaps that is why time travel stories feel so deeply human. They are not really about physics. They are about regret and hope loss, and longing about the wish to return and the need to move on. Every traveler who steps into the past seeks not to change history, but to heal it. Every visitor to the future carries the quiet question: did it all matter? Time travel at its core is our way of reaching across the divide between what was and what will be, to make peace with both. And maybe in some quantum sense we already do. In the timeless haze of possibility, all moments coexist. The universe viewed through Einstein's block of spacetime holds every event from the first spark of the Big Bang to the last flicker of a dying star within a single eternal geometry. The past is not gone. The future not yet born. Both simply are. In that sense, every heartbeat you've ever had still beats somewhere in space-time. When we gaze at the stars, we are not seeing the present, but the past light that began its journey millions of years ago, arriving just now to meet our eyes. The night sky is a museum of time travel. Each star is a messenger from history, a luminous echo of what once was. Even the sunlight that warms your skin is 8 minutes old. A brief but measurable delay between creation and touch. We are constantly living in the past, illuminated by light that has traveled to find us. So perhaps the dream of time travel is not about bending physics, but about seeing the miracle already around us. We are immersed in a universe of motion and memory, where every photon is a letter from yesterday, and every breath shapes tomorrow. Time travel is not waiting in the future. It is happening in every moment as we reach forward with imagination and backward with memory, creating continuity from change. And if one day humanity does find a way to step across the barrier, to touch another moment directly, it will not be to escape time, but to understand it more fully. Because deep down, we do not truly wish to conquer time. We wish to belong to it, to feel the great pattern of before and after as part of a larger harmony. The dream of time travel, then, is not the desire to rewrite life, but to cherish it, to hold every fleeting second as if it were infinite, because in some way it already is. What if, after all this exploration, the clocks, the relativity, the bending of space-time, the quiet ticking of our own bodies, we were to discover that time itself isn't truly real, that it's not a cosmic river or an arrow, but a mirage produced by the way we notice change? This is the question that rests at the edge of physics and philosophy alike. Not the kind of question we answer with equations, but one that hums quietly beneath existence, an unspoken riddle whispered by the universe itself. For most of us, time feels like the most real thing there is. We see it pass in the turning of leaves, the fading of light, the shifting of shadows across a room. We feel it in our bones, as age in our hearts, as memory in our minds, as anticipation. And yet, when physicists look deeper into the quantum fabric of reality, they find no clear sign of time. There are no particles of time, no ticking gears hidden beneath the atoms. Instead, there are relationships, patterns, and change, but not time itself. To understand how we reach this strange frontier, it helps to remember that humans once imagined time as absolute and eternal. Isaac Newton saw it as a perfect universal rhythm, a steady pulse ticking outside of reality, governing all motion. Then Einstein came and shattered that illusion, showing that time stretches and folds depending on motion and gravity. Time, in his vision, is not an independent stage, but a part of the cosmic fabric itself. Each of us carries our own strand of it, and there is no single now that unites the universe. This realization gave rise to what philosophers call eternalism, the idea that all moments in time exist at once, equally real. The past, present, and future are not flowing one after another. They are already there, laid out, like a vast four-dimensional landscape. In this block universe, your birth, your present thought, and your final breath all coexist, not as possibilities, but as coordinates in space-time. We move through them the way light travels through glass, carried by perception from one slice to the next. In this picture, the present is not a privileged instant. It's simply where consciousness happens to be looking. The past has not vanished. The future has not yet arrived, but all are still there, waiting, woven into the fabric of existence. It's a vision both unsettling and strangely comforting, that perhaps nothing is ever truly lost, that every moment once lived remains forever somewhere in the architecture of reality. But there's another way to see it. Some philosophers and physicists argue that time doesn't exist at all, not even as a dimension. According to theories in quantum gravity, when we try to describe the entire universe as a quantum system, time disappears from the equations altogether. In the Wheeler-DeWitt equation, a fundamental equation that attempts to unify quantum mechanics with general relativity, there is no variable for time. The universe, in its deepest description, seems timeless, a frozen wave of infinite possibility. If this is true, then what we call time may simply be an emergent property, a side effect of change, a pattern that arises when complex systems observe other systems, like temperature, which doesn't exist for a single molecule, but emerges from many molecules. Moving together, time might emerge from the collective behavior of the universe. In other words, time could be a story, The cosmos tells itself, a measure of how events relate, not a thing that exists independently. This idea, proposed by thinkers like physicist Julian Barber, invites a radical shift in perspective. Barber suggests that the universe is made of countless nows, static configurations of everything that exists. Each now contains all of reality frozen in a single complete moment. What we experience as time passing is simply our consciousness moving through these nows, connecting them into a narrative. It's not the universe that flows, it's our perception that stitches the still frames into a film. If this sounds abstract, consider the way a movie works. On the reel, each frame is still. Only when light shines through the film and our eyes blend the images together do we perceive motion. Perhaps existence works the same way. The universe is a reel of timeless frames. Our awareness is the projector. What we call time is the story we see unfolding. But if time doesn't exist, what of memory? What of change? The answer lies in the very fabric of interaction. Even if time is not fundamental, change still is. The world doesn't stay still. Particles collide, energy shifts, stars ignite and fade. Each transformation leaves traces, and those traces form the illusion of sequence. We remember because our brains, our cells, our atoms are built upon the principle of irreversible change. Memory is not evidence of time's flow. It is the architecture of entropy. Still, the notion that time might not exist stirs something emotional, even existential. If the universe is timeless, then what is a life? What is a moment? Perhaps they are not fleeting after all. Perhaps every instant we've ever lived, every breath, every word, every glance, is preserved eternally suspended in the structure of being. And perhaps death, then, is not an ending, but a shifting of attention, a step beyond the present, now into another that the living cannot yet perceive. For all its mystery, this perspective doesn't diminish time, it makes it sacred. If time is not a river, but a tapestry, then every thread matters equally. There is no past to regret, no future to chase, only the infinite present, rich with possibility. To live fully in this now is to touch eternity. And so, after centuries of building clocks, mapping stars, and measuring seconds, we arrive where we began, at the quiet wonder of existence itself. Whether time flows or stands still, whether it is real or imagined, it remains the measure of meaning. We need time. Not because the universe demands it, but because life does. Time gives story to motion, grace to change, and beauty to impermanence. So perhaps the truest understanding is not to solve time, but to surrender to it, to let it cradle us as both mystery and guide. Time may not exist as a fundamental thing, but it exists for us. It gives texture to love, shape to memory, and direction to hope. It is the mirror in which consciousness sees itself. And when you close your eyes tonight, listening to the soft ticking of your own heart, remember that rhythm is older than the stars and yet utterly your own. Time, whether illusion or truth, lives there, in the pulse that connects you to everything that ever was and ever will be. And now, as the universe drifts back into silence, may your mind rest in the calm between stars. And so we arrive not at the end of time, but at a pause within it. The clocks may continue their steady ticking, but here in the quiet between heartbeats there is only presence. You've traveled through ages and atoms, from ancient sundials to the slow drift of galaxies, only to find that every moment, every breath, was part of the same infinite now. Time, whether a river or an illusion, remains our constant companion, shaping us as we move through its light. So, let this stillness linger as you rest. Feel the universe holding its breath beside you, calm and eternal, the stars keeping watch. If you'd like to wander further through these quiet wonders, you're always welcome to return, where curiosity rests easy and the cosmos dreams in silence.